Hello. Hello.
Yes, ma'am.
Okay,
Yes, ma'am.
Yes, ma'am.
so,
Yes,
right. So we have, okay. Okay, right. So let's continue. I have shared this example with you. Okay, you can see it. Okay, now.
Yes, ma'am.
Okay, good. So this is an example of a mass spring system. So you can see that there is a box here. This box, okay. So this box is moving with a velocity or with V1 towards a spring. Okay. This spring is attached to a wall. The spring constant is K. Okay. So the mass of the box is 2 kg. So the mass in this case is equal to 2 kg. And the velocity is 4 meter per second. So this is equal to 4 meter per second. Now it is moving towards the spring and it will reach the spring and then it will compress the spring, right? It will push the spring towards the wall. When it compresses a spring, a kinetic frictional force from the floor of magnitude 15 Newton acts on the package, which means that there is a kinetic frictional force Fk is equal to 15 newtons. Okay, and the value of K has been given to be 10,000 newtons per meter. So we have the value of this spring constant is equal to 10,000 newtons per meter. So these are the values we have. What do we have to find? We have to find the distance d by which this spring will be compressed. So we have to find a certain distance d by which this spring will be compressed when the box pushes the spring into the wall. So let's try to understand this. In order to understand this, what are the changes that are taking place? We have two states. Okay, first of all, we have defined two states, a state 1 and state 2. State 1 corresponds to the initial state of the box or the package, right? And state 2 corresponds to the state in which the package is stopping. After pushing the spring, the package will stop. So that is state 2, when the spring will be compressed. Okay, so in this case, for both states, the mechanical energy of the system will be a sum of the package's kinetic energy, which is K is equal to half mv squared. This equation that we've already studied in the previous chapters, and the spring's potential energy, which is U is equal to half kx squared, which we just talked about. So therefore, for state 1, the potential energy is 0 because the spring has not yet been compressed in state 1. And the package has a speed v1. Therefore, the state 1 energy will be a sum of k1 and u1, where k1 will be equal to half mv1 squared and u1 is 0. So this is the first expression. For state 2, k is equal to 0 because the body has stopped moving, and therefore a compression has been produced by a displacement d, and this is the change in position along the horizontal axis. So instead of kx squared, we will now write kd squared here, and the kinetic energy, as we just said, is 0 because the body is not moving. So we have the mechanical energy expression for the first state, and we have the mechanical energy expression for the second state. Now we know that there was an equation 8.31. Let's look at the equation 8.31. This is the equation. This one. Delta thermal is equal to FKD. The thermal energy change is equal to the product of the frictional force multiplied by the displacement d that is produced. So this is what we are going to use. And in order to use this, we come back. So the equation 8 was delta E thermal is equal to Fk multiplied by D. So this one. So we know that mechanical energy is a sum of the kinetic energy, potential energy plus the this
Thermal energy.
the thermal energy. Very good. So the thermal energy is FKD. So we put the expressions. E mechanical 2 was half KD squared. We put it here. E mechanical 1 was half mv v1 squared. We put it here. And the thermal energy is FKD. We put it here. Now we substitute the values. We have the value for K. What was the value for K? 10,000 Newton meters. So this was half multiply by 10,000 Newton meters multiply by d squared. We don't know d squared. So d squared is equal to half multiply by the mass. The mass was 2 kg. 2 kg multiply by the velocity squared. The velocity was 4. So 4 squared is equal to 16. So minus Fk. Fk is 15 newtons multiplied by D. We don't know D. Okay. Now we can cancel this and we will get 5,000 here. Right? And we can cancel this and we will get 16. And when we do this, we get this equation 5,000 D squared plus 15D minus 16 is equal to 0. So what kind of an equation is this? What kind of formula can we use to find D?
Quadratic equation.
The quadratic equation. So you remember that I showed you the table in the beginning of the book. In that table, you have the quadratic equation formula. You can use that formula to find D. So what was that formula? D is equal to
Minus B.
Minus B. So
Plus
minus B plus minus
under
B
root
square
B
minus
square
4AC.
B squared minus 4AC under the root divided by
2A.
So now you have to see what is B in this case. B in this case is
15.
15
so this is equal to minus 15 plus minus B squared is 15 squared. Okay. Minus 4 multiplied by A is
5,000.
5,000 multiplied by C is
16.
minus
Minus 16.
minus 16. Remember the signs, okay? Otherwise you make a mistake. And then whole divided by 2 multiplied
10,000.
by 5,000.
5,000.
Now you can solve it and you will get an answer. And this
मैम इसके दो आंसर्स आएंगे.
हाँ बिल्कुल दो आंसर आएंगे. Then you have to see which answer will make sense. कौन सा ज्यादा feasible होगा इसको calculate करके देखना. ठीक है? So in this case you can see you will get the answers in meter and you can convert it to centimeter if you want. ठीक है, depends. अगर आप problem कर रहे हैं and the answers are given in centimeter. Initially, if all the quantities are in SI system, सब कुछ SI में था ना. The mass was kg, the velocity was meter per second, the energy was joules, वो बल्कि force was in newtons. So everything was in SI. So therefore, the answer is in meters. The answer you will get will be in newtons. Okay, ठीक हो गया?
Yes, ma'am.
Good. So I will stop here. Please practice this chapter. आपके homework 2 की deadline क्या थी भला?
4th December.
हाँ, तो प्लीज उसको कंप्लीट करके सबमिट करें. उसके बाद आप ये जितने चैप्टर्स पढ़े इनकी तैयारी करें फॉर द मिड टर्म. प्रिपेयर फॉर योर मिड टर्म. ठीक है?
Okay, ma'am.
ठीक हो गया. So please follow the assessment plan that we have already discussed and also it's posted on Moodle. Look at the course outline.
Ma'am, what about attendance?
हाँ,
Attendance.
अटेंडेंस लेनी है दोबारा. ये कौन बोल रहा है?
I'm Anam.
अनम.
मैम एक्चुअली मैं 5 मिनट लेट थी क्लास में.
अच्छा, इसलिए आप चाह रही हैं दोबारा अटेंडेंस हो जाए. चलो लेट्स सी. सरमद. सरमद इज नॉट देयर. अमार नो. अबू बकर.
Present.
अच्छा. फातिमा नो. मोहम्मद उस्मान नो. अनम यस.
Present.
हाँ. बिलाल.
Present, ma'am.
अनम आप इसका मतलब पहले पार्ट में थी ही नहीं. हमजा डार. हमजा
Yes,
डार.
ma'am. Yes, ma'am.
अच्छा. और we have फरीदुद्दीन.
Yes, ma'am.
केसलर. जरिश. हारिस. मुआज. देखा, मुआज भी चला गया. अच्छा. हाफिज इब्राहिम.
Present.
एंड हुमा. अलीना. मोहम्मद.
Present.
अलीना इज देयर राइट. मोहम्मद हुनैन.
Yes, ma'am.
Yes, ma'am.
ओके. राना शहबाज.
Present, ma'am.
सनिया.
Present, ma'am.
अरीशा.
Present, ma'am.
चांद.
Present, ma'am. Present.
माइजा. नो. यूसुफ. पतरस. अबीरा. इज अबीरा हियर? अबीरा. अबीरा कहाँ है? नादिया. हयान. शेरल. अशरेफ. हुदा जहूर. अमीलिया.
Present, ma'am.
ओके. बिस्मा. सदीकुल्ला. सुहेब. तलहा.
Ma'am, present. Suhaib, present, ma'am.
अच्छा, सुहेब प्रेजेंट है. तलहा कहाँ है? अली जुल्करनैन.
Yes, ma'am.
ओके गुड. सो ये बच्ची नहीं बोली अबीरा. ये लॉगिन करके गायब हो गई है. ओके ठीक है. ओके. सो प्लीज प्रिपेयर, कंप्लीट योर होमवर्क 2 एंड स्टार्ट प्रिपेयरिंग फॉर योर मिड टर्म. ओके.
Okay, ma'am. Okay, ma'am.
ओके. टेक केयर. बाय.
Yes, ma'am.
Goodbye, ma'am.
बाय.
Allah Hafiz, ma'am.
अल्लाह हाफिज.
Allah Hafiz.
अल्लाह हाफिज.
Thank you, ma'am. Allah Hafiz.
अल्लाह हाफिज.